Greetings to everyone. Myself, Dr. M. Harivanan, working as Associate Professor in Department of Civil Engineering in Mari Lakshman Reddy Institute of Technology and Management. It is an autonomous institution which is located at Dindukal, Hyderabad. I am handling the subject of surveying and geomatics to the second year civil engineering students. Today we are going to discuss about different types of levels and how to do temporary adjustments during the leveling process and different methods of leveling and booking of levels. These topics we are going to cover by today. So first we are going to discuss about different types of leveling equipments. So here we are going to use four type of instruments. Okay, one is dumpy level, second one is tilting level, third one is automatic level, and fourth one is digital auto level. In general case we are going to use only two things. One is dumpy level. Okay, this instrument only we are going to use, but along with the leveling instrument we need another accessories like leveling staff. Okay, it has the 4-meter height, and with the help of leveling staff only we are going to read the height of the particular land or particular point position. Okay, from that we are going to get a reduced level of particular location. Okay, now we are going to discuss about types of leveling equipments. Okay, so here we are going to discuss first tilting level. So tilting level is the instrument which has the adjustments, okay, so that the telescope can be rotated to some few degrees. Okay, like in the vertical plane, either like this or like this. Okay, first up to some degree. Okay, with the help of tilting screws. That's why this leveling instrument is called tilting level. So here we are having some adjustments to rotate our telescope. Here the tilting screw is available. Okay, next, automatic level. First we should know the difference between the automatic and the classic split level. Okay, first we should know that here in classic instrument the line of sight is no longer leveled manually, okay, using the tubular split level, which means in the classic model we are going to do all the adjustments by manually. Along with that, the instrument should not maintain its leveling, okay, for the longer time. Okay, but automatic level, okay, the split level and the leveling process should be available for the longer time. Okay, which means the instrument itself has been leveled automatically within a certain tilt range. Okay, this can be achieved by the compensator in the telescope, which is present in the telescope. So this is the difference between the automatic level and the classic split level. Okay, so normally in laboratory purpose we are going to use classic split level. Okay, but in the field our continuous working, okay, now at that time we are going to use auto level, so that the process the leveling process. Okay, now and the after leveling it can maintain its level for the longer time. Okay, so that the instrument itself it can adjust. The advantage of automatic level. Okay, now it is very simpler to use and it has high precision, so that the error per kilometer, okay, now the reading in the error, okay, per kilometer maybe varies between plus or minus 0.5 mm to 0.8 mm, okay, in the forward as well as backward leveling. Okay, and the high speed. So if we are going to do the fly leveling process with the help of auto level, okay, now we can achieve the entire process within the less time. Okay, so since the level should be done easily. Third one, our dumpy level. Okay, so in common cases and in our laboratory also we have seen this instrument. Okay, so this is called our dumpy level. So we will discuss about something related to our dumpy level. So it is a simple and compact and stable instrument. Okay, the telescope is rigidly fixed, therefore it cannot be rotated in the vertical plane. So we cannot rotate it in the vertical plane. Okay, so we can rotate in the only horizontal plane. Okay, so the movement of vertical plane cannot be done. And it has a long bubble tube and it is attached in the telescope. So this is our bubble tube, it has been attached in the telescope, so that we can see our instrument was properly leveled or not, that we can check it by this. And fourth one, the instrument is stable and retains its permanent adjustment for long time. So permanent adjustments, it is are purely related to our instrument, so that the precision, higher precision can be achieved. Okay, when we are using this instrument. So this kind of dumpy level only we are going to use in common. Okay, in the field also in the laboratory purpose. Next, diaphragm. So diaphragm in the sense, here we are, while focusing in the, here we are having some arrangement. This is called the eyepiece, this is called the object piece. Okay, so like this screw, this is focusing screw. Okay, now we are having one attachment in this side. Okay, so here we are having some arrangement, that arrangement is called diaphragm. In the diaphragm we can have the crosshairs. Okay, which is made up of either silk thread or platinum wire, which is placed at the plane at which the image, okay, now the image of the object can be visible clearly by us. Okay, and with the help of that crosshairs only we are going to bisect the image or bisect the leveling staff. Okay, so the diaphragm has the crosshairs maybe like this. Okay, now this is vertical hairs, these are all horizontal hairs. Okay, now this is middle hair, this is upper hair, this is lower hair. Okay, and with the help of our middle, upper and lower hair we can read the leveling staff reading. Okay, and what is the use of vertical hair? Now the question. Okay, so the, in order to maintain the verticality of the leveling staff wherever we are going to see in the field. Okay, now so that the staff whatever we are going to see through the diaphragm, okay, now has to be in the exact vertical form, then only we can read the reading, whatever it is we are going to get it correctly. Next, the components of dumpy level. So from the bottom we can start it, okay. Now first one is tripod stand. So this is the accessory, okay. So without tripod we can't fix our instrument, okay. So first we need to place the tripod over the station point, okay. Over the we have to leveled manually, okay, now the tripod. Over that we have to fix our instrument. So the instrument consists of first one, leveling head or trivet. This is nothing but the lower plate. Okay. So next one, we are having foot screw. Over the foot screw we are having one arrangement that is called a tri-brach. This is nothing but upper plate. So between the upper plate and the lower plate we are having the foot screws. So by adjusting the foot screws we are going to make this longitudinal bubble is at center, then only our entire, that is our leveling process, okay. So that in the horizontal plane the line of sight should be lies in the exact horizontal plane, okay. Now that should be done with the help of these foot screws. By rotating these foot screws the longitudinal bubble becomes center at all position when we are going to rotate the telescope in the horizontal plane. Next, so circular compass. So here we are having the angles which is 0 to 360 degree. Here there is no magnetic north or magnetic south, okay. Now it is generally made up of 0 degree to 360 degree. It won't indicate any magnetic north, okay. Next, eyepiece and object glass, okay. So here the eyepiece, I said the entire system of diaphragm, focusing screw, everything available here, okay. Now so diaphragm we are having the crosshairs so that we can get the readings, okay. Now that is we are having the crosshair like this so that we can able to read the readings through the diaphragm. So eyepiece, it consisting of one rotating arrangement in that, okay. Now here it is, we can rotate it. So by adjusting the eyepiece we can able to view these crosshairs clearly by rotating clockwise or anti-clockwise. And focusing screw, so by rotating the focusing screw we can able to view the object which are present in front of the telescope, okay. Now that should be very clearly with the help of rotating the focusing screw. Next, okay, cross bubble. So like a longitudinal bubble we are having another bubble which can be perpendicular to the direction of longitudinal bubble, which is called the cross bubble. So these are all the main components in the dumpy level. So now we will discuss about these components. So tripod, the tripod stand consists of 3 legs which may be solid or framed to support above the 3 parts of the level. So next, leveling head. So leveling head generally consists of 2 parallel plates, okay, 2 parallel plates with 3 foot screws. So the upper plate is called tri-brach and the lower plate is called trivet, which can be screwed on the top of the tripod, okay. So leveling head has performed three functions. One is to support the telescope, second one is to attach the level to the tripod, third one is to provide a mean for the level. Okay, now by adjusting the foot screws we are going to make the bubble center, so that in the horizontal plane it has, the telescope has in the exact horizontal plane movement. There is no deviation or undulation. Okay, while rotating the telescope the line of sight won't change, it should be in the horizontal plane. Okay, now that has to be done with the help of these foot screws. Okay, by adjusting the foot screws. And third one, foot screws. Okay, in general 3 foot screws are available between the upper plate and lower plate, that is tri-brach and trivet. By turning these foot screws the upper plate can be raised or lowered, okay, to bring the bubble to the center of its run. So bubble is nothing but we can have the arrangement like this. This is the bubble tube. Okay, now so here the level is there. So this bubble has at its center, okay, that we are going to make with the help of foot screws. And fourth one, telescope. So it is an optical instrument which is used to magnifying and viewing the image of the object which are present in front of the telescope. Okay, it consists of 2 lenses. Okay, one lens is fitted at the eye position which is called eyepiece. Okay, now and another lens is fitted in the near the object. Okay, now that is called object lens. So with the help of these two we are going to get the readings very clearly. So by adjusting the eyepiece we can get the clear visibility of the crosshairs in the diaphragm. Okay, by adjusting the focusing screw, we are going to get the clear visibility of the object. Then fifth one is level tube. So it consisting of bubble tube. So by adjusting the foot screws we have to make that bubble come to its center position. Then only we can proceed our entire process without any error in their readings or plane. Next topic, the temporary adjustments of level. So before going to start the leveling work, okay, that means before going to start the reading, okay, we have to do some process. Okay, now those process are comes under temporary adjustments. Okay, now this can be done in the field itself by the surveyor. Okay, so for the 3 temporary adjustments are: first one is setting up the instrument, second one is leveling up the instrument, third one is elimination of parallax. So under the first one, setting up of instrument, okay, we have to select the suitable position of the point in the field. And second thing under this title is fixing the level with the tripod stand. Okay, and second one, leveling up of instrument. Here we are having 2 operations. One is approximate leveling by legs of tripod stand, so that we are going to create a leveled surface of the tripod. Second one is perfect leveling by foot screws. Okay, by adjusting the foot screws we are going to get the perfect leveling of our bubble tube. Third one, elimination of parallax. Here focusing the eyepiece, focusing the object glass and taking the staff readings. So these processes comes under temporary adjustments of level that we are going to discuss now. So first one, setting up of instrument. So selection of suitable position. Okay, a suitable position is selected for setting the level. From this position we can make or we can get a lot of observation without any difficulties from the field. Okay, that we have to ensure, like the way we have to choose one position of a station point. Second one, fixing level with the tripod stand. So our instrument dumpy level, we have to fix it on the tripod stand. So these two operations are comes under setting up of leveling instrument. Second operation, that is leveling up. Here what we have to do means the bubble which are whatever present in the longitudinal section, okay, now that we have to get at its center. Okay, now for that we have to do two process. One is approximate leveling by the legs of tripod. Here what we are going to do, first we have to keep two legs, okay, now, and another leg, the third leg, okay, now we have to adjust either front or back or left or right side, so that it has been leveled somehow perfectly, okay, now by the eye view. And second one, perfect leveling by the foot screws. Now what we are going to do, so in the telescope, okay, now we are having the longitudinal bubble. Okay, so that position, so that the telescope will be parallel to the two foot screws. Likewise we have to make. Okay, now after that, by adjusting the two foot screws simultaneously, either inside or else outside. So this process, by rotating the foot screws simultaneously towards inside or towards outside, the bubble has to get come to center position of the bubble tube. Okay, now likewise we have to do the adjustments. Okay, now once after getting the bubble at its center, okay, now just to stop the process, okay, now by adjusting these screws. Okay, now after that, just to rotate our telescope, okay, now so that it has to get perpendicular position to the previous position. Okay, so it has to get the position like this, so that the bubble has to be here. Okay, now adjusting the only one screw which are present, okay, now either clockwise or anti-clockwise, so that the bubble comes to its center position. Okay, now once it reaches its center position, we just stop the process. Okay, now by doing this to process continuously, we have to do until the bubble is center at all position. When we are rotating the telescope in the horizontal plane, the bubble has to be at its center in the entire rotation. Okay, now that we have to ensure. This process is called perfect leveling by the foot screws. So this is called parallel adjustments, and second one is called perpendicular adjustments, that we have to ensure. And the third one, that is elimination of parallax. So here it involves three operations. One is focusing the eyepiece. By focusing the eyepiece, okay, that is either we are having the eyepiece arrangement like this. Okay, either you can rotate clockwise or anti-clockwise, so that we have to make the clear visibility of the crosshairs which are present in the diaphragm. Okay, so second operation is focusing the object lens. Okay, so here with the help of focusing screw which are present in the telescope, by rotating the clockwise or anti-clockwise, we have to make the clear visibility of the object which are present in front of the telescope. So this can be done with the help of focusing screw. Okay, now meanwhile we have to look at from the eyepiece, then only we can view the clear visibility of the object. So that clear visibility of object as well as the clear visibility of eyepiece should be done. Okay, then third one, taking the staff readings. Here, after receiving the clear visibility of object as well as our diaphragm crosshairs, we can take the readings with the help of our instrument. So this process, okay, now during this process the bubble which are present in the level tube should be at its center through the entire process, that we have to ensure. So these are all the process comes under temporary adjustments of level. So next, types of leveling operation. So there are 6 types of leveling process. Okay, one is simple leveling, second one is differential leveling, third one is fly leveling, fourth one is longitudinal or profile leveling, fifth one is cross sectional leveling, sixth one is check leveling. So during the entire process of leveling, we among these 6 process, the one process or 2 process we are going to do. Okay, so this is the different types of leveling operation. Now we are going to discuss this process elaborately. So first one is simple leveling. So whenever we are need the difference between the 2 points, okay, now that is the height difference between the 2 points, okay, now at that time we are going to use simple leveling. For example, we want to know the difference leveling between the point A and B, that means the height difference. So what is the height difference between the point A and B? Okay, whenever we want to know this, okay, now, and these points should be very nearby. Okay, now at that time whatever the leveling we are going to do, that leveling is called simple leveling. So first we are going to set up the instrument at between these 2 points, and we have to do all the temporary adjustments. Okay, now after doing the temporary adjustment, the line of sight is in the horizontal plane. Okay, now it won't change anywhere. So that first we have to keep the leveling staff at point A, and we have to read the reading. Okay, now so I already said leveling staff consists of 4 meter height and it has the reading of 5 mm. So 5 mm means we can have alternate black and white band. Okay, now so that each band black and white has the height of 5 mm. Okay, so that our least count of the leveling process is 5 mm. So after leveling this, we have to read this reading so that we can get it. Similarly, we have to shift the leveling staff from point A to B, then we have to read the reading so that we can get the leveling difference between these 2 points by deducting the staff readings at A and staff reading at B. Next one is differential leveling. So the difference in elevation between the point A and B is too high. Okay, now at that time there are the lot of obstacles are present in the field. At that time we are in need of the several change point. Okay, now change point is nothing but shifting of instrument, that is leveling instrument from one place to another place. it may happen in the field. Okay, now that is called differential leveling. So that finally we are going to get the difference between the elevation difference between the point A and B. We are going to get it by means of, after doing some process in the leveling. So this method is also called compound leveling or continuous leveling. Okay. Third one, fly leveling. So fly leveling is also similar to differential leveling, but here the difference is the differential leveling is done in order to connect a benchmark to the starting point of the alignment. Okay. So in previous differential leveling we have seen that the level difference between the point A and B we have done with the help of our continuous leveling, but in fly leveling the reading has been connected with the benchmark to starting point of the project, which has been done continuously. Okay, now it has been done continuous action. Okay. So here we no need to take any intermediate site reading, only we are in need of back site and foresight reading in both differential leveling as well as in the fly leveling. So for this instrument position O1, this is backside reading and this is foresight reading, and for the instrument position O2, this is the backside reading and this is the foresight reading, which means this is the first reading, this is the last reading. Okay. And for the reference of O3, this is the backside reading and this is the foresight reading. Here one thing you remember, that for each and every position of instrument station, that is O1, O2, O3, O4, the line of sight height gets deferred. Okay. That's why we are calling it as the first reading and last reading. For this position, this is the first reading and this is the last reading. Okay. That you should remember. So fly leveling is used to get the, or to check the accuracy of the work. Okay. So that we have to, when we are doing the calculation now, at that time we have to get the exact benchmark reading. So if I am going to take benchmark reading as 100 while starting the work, okay, now, and when I am going to finish the work, I have to get it back with the help of fly leveling. I have to reach my first point once again. Okay, now. So this observation has been made or tabulated. Okay, now while doing the calculation, I have to get the same value of 100 as the benchmark reading. Okay, now that, then only my entire work is correct. Fourth one is longitudinal or profile leveling. So whenever we are going for the railway, roadway, canal laying and water pipeline scheme, okay, now those works has this kind of profile leveling. Okay, now, so that I already said, so the length of the field have some kilometers of distance, that time we have to take the readings in some common interval along the length direction, those with some common interval. Okay, now those readings are called as longitudinal leveling readings. Okay, now, and cross sectioning along the widthwise, if I am going to take the readings, okay, now those readings are called cross sectioning. Okay, now, so whenever we are going for profile leveling, it consists of both longitudinal as well as cross sectional details together we have to take. Next, check leveling. So once we have finished the entire work, we have to check our process is correct or not. Okay, in order to ensure our work accuracy, we have to do the fly leveling from starting point to end point, okay, or end point to starting point till the benchmark wherever we can have. Okay, now so that this process will be called as check leveling. So this can be done for the day-to-day work. Okay, now so if I am going to do the work for this day, okay, now I have covered some 2 kilometers, so that 2 kilometer work whatever I have done, whether it is correct or not, that I have to check it by the help of end point to the benchmark reading. Okay, now so we are ensuring our accuracy of the work by day to day while doing the leveling process. So this process is called check leveling. So next, booking and reducing levels. This means in the field we are going to see the leveling staff reading, and we have to note that reading. Okay, now with the help of telescope or instrument we are going to see the leveling staff reading, and those readings should be entered in the field book. Okay, now so how the way we are going to enter in the field book? There are two methods. Okay, now one is collimation or height of instrument method. Second one is rise and fall method. Among these two we can use any one method based on our convenience. Okay, so now we should see how we can tabulate this. Okay, now so this table denotes our field book. So how the way we have to enroll our reading in the tabular form or in the field book. So we are having three readings. One is back sight, so which is the first reading whenever we are going to take it in the fielding or in the field. Okay, and foresight is the last reading whichever we are going to take it for the instrument position. Okay, now so the backside and foresight. In between the backside and foresight, how many readings are we are going to take? Those readings are comes under intersight. Okay, now for example, my instrument is here. I have done all the temporary adjustment so that I made the line of sight horizontal in the horizontal plane. Okay, now this is my field. Okay, so first this is my benchmark. Over the benchmark I am going to keep my leveling stuff. So this is my first reading. For example, I am getting this reading as some 1.5 meter in the leveling stuff. So this 1.5 I am going to take it, or I am going to write it in the back side. So here I am going to write this one as in the remark as benchmark. Okay, and next I am going to, I already said it is purely depend upon my focal length of the dumpy level. Normally 100 meter is clearly visible, so that from here it is 100 meter and from here it is 100 meter. This is forward and backward. Okay, so next to that I am going to take the reading somewhere here. Here I am getting some 1.3 meters. Okay, I am going to write this one in intersight. Next here, so I may get some 2.1. I am going to write it in intersight. Next I am going to take it somewhere here. So here I am getting some 1.1 1.905. So 1.905. Next I am taking somewhere here. So here it is coming as 1.650. So 1.650. Okay, so this is my last point. Since after that I cannot view my reading. Okay, now here I am getting some 1.55. So this is my last reading which can be taken with respect to this instrument position. So this reading I am going to write it in foresight 1.550. After that I never change this instrument, I never change this leveling staff position. Okay, now just I am going to change my instrument position from here to somewhere here. Okay, now and here I have to do all the initial adjustments, that is temporary adjustment, and I have to view this same position of leveling staff once again. At that time I am going to get some reading, that is 1.490. For example, I am getting means this reading I am going to write it in the back side 1.490. So likewise my entire process to be completed in the field. Okay, this is my change point position, so that I am going to denote it as CP1. Okay, so this is called booking of level by collimation or height of instrument method. Okay, now so here the another column we can have, those columns are height of instrument, reduced level and benchmark. So I already said I am benchmark reading, I am going to take it as 100. If I know the benchmark reading, I can take whatever the reading they have. Okay, now if I am not having, I have to take it as 100 as my value. So now height of instrument is nothing but 100 plus this 1.5. So these 101.500. So these columns are comes under field work. Okay, now so whenever I am doing the field work now, meanwhile I have to write these values. Okay, now and this part and this part we can do it in the office. Okay, so this calculation we can done in the office. Okay, so likewise we are having another method that is called rise and fall method. So same thing we can backside, interside, foresight. Instead of height of instrument we are having rise and fall. There are two. Okay, now so this method have some advantage and this method have some advantage. Okay, that we will discuss right now. So collimation method and rise and fall method. First we will discuss about collimation method. It is the rapid and it involves some few calculation. Okay, I already said only we are having height of instrument, with that we can arrive our reduced level of the points. Okay, now there is no check on the reduced level of intermediate points, correct? Okay, just we are going to write the intermediate site readings. Third one, errors in intermediate RLs cannot be detected. Okay, so just we are going to write the intermediate site and whatever the error it happened now, that we cannot find it. Okay, now and even though that error won't affect the entire system. Okay, now that also we could remember. Fourth one, there are two checks on the accuracy of RL calculation. This is nothing but this is our arithmetic check, that is sum of backside difference or minus sum of foresight. Reading should be equal to last RL minus first RL. This is the check we have to do, which means so sum of the backside reading minus sum of the foresight reading, okay, now which is equal to our first RL minus last RL. We are going to keep it here, okay. Now this difference should be equal to this difference, okay. And fifth one, this system is suitable for longitudinal leveling where there are a number of intermediate sites, okay. So mostly we are going to use only for profile leveling, okay. So the both method can be adaptable for based on our convenience, but especially this collimation method is suitable for profile leveling, okay. And rise and fall system we can discuss right now. So it is a laborious involving several calculations. Yes, here we are having rise and fall, reduce leveling, everything, okay. So we have to do two things, and there is a check on RL of intermediate points, okay. So here we have the continuity between the each and every readings here, whatever present in the rise and fall system, and errors in the intermediate RL can be deducted, okay. So I already said there will be a continuity between the first reading to last reading, so that if there is any error we can find out easily, and those error can be rectified also with the help of rise and fall method. And there are three checks here: sum of backside and difference sum of foresight, last RL difference first RL, along with that sum of rise and sum of fall has been included here, so that there will be a three checks, okay, so that our calculation is correct or not, that we can check it easily. And this rise and fall system is suitable for fly leveling or differential leveling, since there is no much intermediate sites, so that our calculations becomes easy. So when we are using collimation system, whatever the error in the intermediate site, no, that won't affect the entire calculation system. That's why we are going to use this collimation method for profile leveling, since profile leveling involves and it have large number of readings, since we have to take longitudinal as well as cross sectional, both the ways we have to take. That's why it have large number of readings. But rise and fall system, okay, now there will be the continuity between the first reading to last reading, that means first backside reading to last foresight reading, okay. Now so if there is any error in the intermediate sites, automatically it affects the entire calculation, so that we have to recheck from first reading to last reading, so it makes the process very tedious, okay. That's why this work or this method we are going to involve in the fly leveling. So in the fly leveling and the differential leveling, we are going to use only backside and foresight reading, okay. No, there is no intermediate side readings, okay. This is the advantages and the disadvantages and the process of collimation method and the rise and fall system method. Next, sources of errors on leveling. So there are three types of sources. One is instrumental error, another one is personal error, and error due to natural causes. So under instrumental error, okay, now there are some permanent adjustments, okay. Now the permanent adjustments of instrument, if it is get damaged, then automatically whatever the reading we are going to see, no, it is the error reading, okay. Now so that it won't happen, okay, now, and it will happen after some long duration, okay, now. So the periodic maintenance of the instrument has been ensured. Second, the internal arrangements of the focusing tube is not perfect. So if the focusing tube is not maintained properly, then automatically the line of collimation is not lies in the horizontal plane, okay, now. So we won't get the reading as correct automatically. Third one, the graduation of the leveling staff may not be perfect. So that also we have to check the leveling staff graduation. So each, I said, black band and white band, okay, now each has the width height of 5 mm. So that 5 mm each line has to get it, otherwise that entire system of reading, whatever we are going to read, that will get affected. Personal error, this is purely denotes us, okay, that is it has been done by purely by the surveyor, okay, now the instrument may not be leveled properly, okay, now that is the bubble tube is won't at center, okay, then the eyepiece and the object glass may not be perfect, so that the parallax cannot be eliminated, okay, the position of the staff may be displaced, okay, so that we cannot get the foresight and backside reading properly, and we are not maintaining the verticality of the staff, okay, and there will be some staff inverted reading. Instead of taking from bottom to top, we are going to take the top to bottom. So that is the error due to manual. And Stadia has, there are some middle, top, bottom in among this, okay, now we have to take it the correct reading, okay, now based on our process. So here we may get a chance of error and the wrong entry in the field book. So these things comes under personal error, that is our manual error. Then error due to natural cause, when the distance of sight is so long, okay, now there will be the curvature correction should be present, okay. That means our field, our earth in the spherical shape, okay, now if I am going to fix the instrument and if I am going to take the long reading, okay, now longest sight, my horizontal line won't be, that is my line of sight won't be like this, it may get deviated like this, okay. So this is nothing but curvature correction. This error may get if our line of sight will be very long, our distance of sight is very long. The effect of refraction may cause wrong staff reading, okay, now so same, if once the curvature may be involved, so we need to take the reading here, but due to curvature effect we can get the reading here. So this is the refraction correction, okay. And the effect of high winds and the shining of sun may give the wrong readings, okay, now so these are all the error caused due to instrument, manual and natural. So these things won't happen during our leveling process. Thank you.